A plus B transpose in the per row column, or B minus A transpose in the per column. So there was some confusion. I guess we have to create three kernels that is clearly mentioned in the question, and for the statement C is equal to A plus B whole transpose minus B minus A whole transpose, we have to do the calculations based on the uh, a per row column kernel, like how we have to launch the kernel, like 1D grid and 1D block. Similarly, for the per column row kernel, we have to do 1D grid and 2D block, and per element we have to do 2D grid and 2D block. So we have to make three kernels, and out of those three kernels, the result should be the same. So for printing purpose also, I got some emails. So either you can print three, either you can print one, or whatever, but the result of the three kernels must be the same because the computation is same. It's not changing. So it's the thing that you can check it, like when you do one kernel, you can check for another whether my result is coming or correct or not. So it's cross verifying your problem only. So what it is there. So if you will see the input format, we have a matrix A, and that is a size of m cross n, and we have a matrix B of size m cross n. So uh, uh, we will take input as m and n, and we will just take input matrix A and matrix B. So there was some confusion for the computation of this matrix Cij, that is this output matrix. Many people started solving it mathematically, and that is not the we are not expecting it that you are solving it mathematically and then trying to do it. So although the result would come correct only, it won't differ that from this result, but we are just expecting that you will do this A plus B whole transpose first, and then we will subtract with B minus A transpose. So uh, also there were some queries like this, like how they can launch the kernel. So if you will see the constant in the section 2.3, it is very large, 2 to the power 13. So I guess if we will launch the kernel with 1 comma m into n, then it won't work, I hope. So that is not the correct way of launching the kernel, because we have to the maximum number of threads per block can be 1024. That is the second parameter in the kernel launch. We have to set like that only. So I also told this over the email. So these are the small doubts that I got, and I cleared it. So okay, so this is a sample input that I gave, and there were some other private test cases also which I provided. I will release the public test cases, and I release the private test cases soon. So there were some submission guidelines also, like you have to submit your assignment with your full name.cu, so that I should understand that uh, like uh, who is the writer of that code, so that I should mail him the appropriate marks along with the problem in the code in the future. So you might get an email from me saying that this is the marks you are getting, and if there would be some problem, you will get the problem also, like what problem is there in your code? Is it compiling or not, or is it running, or how many test cases passed? So these all information you will get from me soon. That's why the motto behind this was to write your full name.cu. Okay, so this is the assignment outcome, like assignment PDF discussion. Now, if you have any, let me open the chat. So there is a chat in the chat. There is a question that, sir, do we need to transpose the same kernel? I guess, yeah. So I guess I also got an email saying like that only. But I guess we need not to do the, like, we should not make another kernel for the transpose. We can do the transpose by interchanging the rows and columns, like Cij to Cji, and we can easily. Yeah, please.
Sir,
Yeah.
uh, sir, so you're expecting to find this A plus B transpose and A minus B transpose, sorry, B minus A whole transpose in the same kernel, right? So, uh, so do we need to maintain another matrix like, uh, so they already told the tiling is not allowed, and the shared thing is also not taught in the previous session. So I think we are not expected that we have to use a shared memory, right?
Correct. Correct.
So keeping that in mind, so and they told that only use the only three kernels, right? So if you take only one kernel, and suppose you want to find A transpose, so in that kernel itself, if you want to find the A transpose, again you have to create a global memory A transpose and put the value of corresponding entries of A in A transpose. And for computing C, you have to use the A transpose values. So in that case, the global memory access would be twice, right? So A transpose is accessed twice. So if you do otherwise, that of course we cannot directly copy all the elements at one go. We have to copy one element, right? So can we do like each element
Actually,
instead of copying into A transpose matrix, directly doing the computation and keeping it in matrix C? Yes, sir. Sorry.
yeah, actually, this is a vector dot product type of this is a vector addition, right? Like like how we do normally for vector addition, vector dot product things. So I guess there is no need of that global memory and this type of shared memory computations. That is also not the intention of this assignment one because uh, that have been not taught in the class, I guess. And I think that after this class, you will see that thing of shared memory in the assignment number two. So I think I already told over this to email to you that for the transpose thing like Cij, we can write Cji, right? So it is a transpose of Cij. Since it is a vector operation, right? It's addition, subtraction on a vector. So vector matrix. So we can easily do such kind of thing. So there is no need of doing these all complex operations and taking any new kernel and uh,
Yes, sir. I got confused because you told in the mail that you have to explicitly transpose. So I just got doubt. So we need to transpose the matrix and save it somewhere and then use it. So the yes, sir. Okay. Thank you, sir.
So, Ashwin, one question here. So, if somebody actually does a transpose in a different kernel, will it cause any issues in our evaluation?
it should not cause because the result is going to be the same, uh, but since it is a uh, it's a like vector operations on matrices.
Mhm.
So like writing one more kernel was not the intention of the problem. Like it was just you need to do some mathematical operations that we do in linear algebra, like
Sure.
already I discussed. So that was the intention. Writing any new advanced thing, right? If you are writing any shared memory or using any new approaches that is not the part of this assignment, and you are going forward, right? So because you are knowing it from previous maybe you have seen some videos or something like that, so it's okay because as long as the result is coming correct, that is okay.
Sure. Thank you. Yeah, Sandeep. So the input will change. We might have to either retransform it to get the original one, or we might have to store the transpose in the another uh, uh, another matrix.
Yes, sir. But it is explicitly mentioned, right? The kernel should take the input matrices and only perform the operation on input matrix. Suppose we launch the another kernel for transpose, then we may not follow. I think we are not following the convention.
I see, I see. Sure, sure. Yeah, Trirag has a question about sharing of the slides and the recordings. The slides and the recordings are made available in the Google Sheet. The slides are made available usually just after the class. The recordings take some time for YouTube to process because it's 1.5 hours. So therefore, by the time it gets available, it might take some time. So you might want to refer to the slides. That's probably going to be helpful from the perspective of assignment evaluation. Yeah, any other questions, concerns anybody has about the assignment? Let's focus on the assignment right now. We'll start the class maybe around 9:30.
Yes, sir. How does taking input and output work? Like, do we need to take input from file and take output from to do the output to file, or we can just use standard input and output?
Yeah, so I also cleared this over the email that since the output is very large, so taking this over the screen will be a little difficult for me for the evaluation purpose. So it was the intention that we have to take the input in the form of uh, some text file, and you have to give the output. You have to read the input from a text file, and you have to print the output in text file. So that for the while I am evaluating, and it might be easy for me to the evaluation, because on the screen, if you will print huge numbers, it is going to be difficult to visualize even to me, and it's taking running a diff will be difficult for me at that time. So taking the input from a file and printing the output to a file was the intention. Yeah, correct. We can redirect the output. Yeah, that is fine. Uh, that we can redirect the output to a particular file and we can check it. That is fine. Yeah. Sure, no problem. If you have not used that, then I have to do some extra work. No problem. As long as your
So,
code is working, like I already told over, like I got around 30 emails. I already told over the email that as long as your code is working, it is not bothering me that how you are using, like like how you are using taking input from file or not. So it's not a problem. If the output is coming correct, that is fine. But it is going to be a little painful for me that I have to do some extra work. That's it. Yeah, please, Aditya.
yeah, in the print, like the printing format, does that matter? Because like I was printing that using the for loops and direct space. There was extra spaces in my output where they were not in the sample output. So will that matter, or you will manually check that?
Yeah, sure. That all these things, because we have a script that is a problem. I think if such things are there, then I have to go the things one by one, and evaluation is going to be pretty it will take some time for me, but that is fine, no problem. I will just look into the assignments one by one.
Okay, yeah, thank you.
So, Chekla, Sandeep is saying that in PDF it is mentioned to not to use tiling. If I intend to do tiling to increase performance, I think we have to bring that tile to shared memory, else we might degrade the performance. Right. So sorry for that. I used the tiling word in the assignment one. I don't know why I use that thing. I should not. I think that is causing confusion to you, and I should tell you that you should not see that line. Just think that that line is not there in the assignment one, and just think it as a vector operations you are doing on the matrices. That's it. You are using some dot product, dot vector additions, vector subtraction. Simply you have to understand like that and do the transpose. So print. So Chinmay is asking that I was not able to print in my kernel on my computer, but it was not. I was able to print on Google Colab. Any specific reason? Um, I was not able to print in my kernel. So I guess you should not print in the kernel. You should just call it. You have to call your kernel in the main, and there you have to print for the checking whether your result is coming correct or not. So that is the correct way. So printing in kernel is not allowed, but I was able to print on Google Colab in a specific reason. I didn't understand that, but it was able to print on Google Colab. If you will, can you please tell me what you want to say?
Yeah, yeah. So the thing is that I was using Google Colab too for some time, and then I shifted to my PC's NVIDIA, basically CUDA. So the code which I was writing on CUDA, it I was able to print in kernel, like as we did in the slides too.
I see it.
So the same did not work for my CUDA installation. Maybe the versions were different. I'm not sure like why exactly it happened because I wanted to debug, and also are there any specific like things which I could use for debugging?
Yeah, for debugging, you can use some DC++ debuggers are there. So, uh, but I guess you can use the print statement instead of using the debugger. So with the help of print statement, you can just debug it for some small test cases where it is coming correct or wrong, and then you can test it for the large test cases.
Okay, thanks.
Any more questions? Like, yeah. So, yeah, please.
Sir, as finding transpose was part of this assignment, I am asking in general. Suppose we want to transpose a matrix,
Yeah.
and I think there are we can divide into two situations that the final transpose matrix can be in the new global memory or in the same global memory. Suppose if it is in the new global memory, if you are intending to write it in the new global memory, I think there is nothing to optimize other than tiling because like we there is no need of shared memory, I guess, because anyway we need to access two global memory accesses. Suppose if we want to write it in the same memory, uh, I think I'm confused how to write it in the same memory actually. Like if we use the shared, I think we have to even though we
I
have
guess I guess we are discussing about the assignment too. I will answer it, but I guess the same like whatever you are telling me, right? These all things will be the part of you in the assignment number two. I guess you have seen the assignment two, and that's why you are asking because you want to do the things. Is it like that?
uh, no sir, actually you told I got confused because in the mail you have written to find the transpose, right? So I
No,
got
no. I already told this is not the part of assignment one, and we should limit it that we have to do certain vector addition and vector whatever the operations are there. These are the all the part of assignment number two. I guess you have seen the assignment number two. That is my intuition.
yes sir.
Yeah. So Harsil, so is this fine? This Are you okay with my explanation? What is your name? Chekla? Sandeep?
Yes sir.
Thank you.
Yes sir.
Yeah, so can you check NVIDIA is enable type NVIDIA? Okay, can you please, Harshil is saying, can you discuss the approach of 1D grid and 2D block for a per column? Okay, I will do that. Uh, okay, so uh, are you able to see this Jamboard?
Yes, sir.
Yeah. So I'll tell. Should I give one example of anyone or should I? Okay, just give me one example that how we have to approach. So I will start with 1D. It's very difficult to do because I am not finding any other way. If you have, tell me. So this is 1D grid and 1D block. Okay, just focus on one thing and then we can move on to if you want to do so. So assume that this is your grid. Okay, this is your grid. Now it's saying that it will be 1D grid and 1D block, right? So assume in this grid you have different numbers of blocks. So these are the block 0. So this is block 1. This is block number 3 and so on. Now inside this block you will have some threads. So assume that this is your thread number 0. This is your thread number 1 and so on. In this block also you have this thread number 0 and thread number 1. So this is your block number 0, this is block number 1, this is block number 2, and inside this block you have certain threads which has thread number 0, this is thread number 1, this is going to be thread number 2, this is thread number 3 and so on. So in this way the things are there. Now what we have to do, we have to write thread IDs. That is the intention. You can see that to write about the thread ID, you have to first go inside this grid. So outside is your grid. So this is a grid. And after going to grid, you have to find the block. And after finding the block, you will get the thread, right? So since it is a 1D grid, so first you have to find out which block you have to go, and inside the block which thread you have to find. That's the intention. So if you are if you are finding difficulty in writing the thread IDs and these all things, so this is the how you have to approach it. So this is the best approach which I found, and I also found it for visualization purpose, that how I have to visualize that which thread and which block I have to go. And if you have any other approach, you can just share me. But this is how I do uh, for my understanding. So what happens now? Assume that you have to now assume that you have to find out the thread ID as one. So if we have to find for this thread ID, this thread, how we will do? We will first move inside this block, and inside moving this block, we will just compute some offset to approach to this. So first is go inside this block and then add some offset to that so that you move to this thread ID, right? So for that, what you will do? So so for that, what you have to do? For that, what we need to do is that we need to write that which block ID we have to go. So this is the zeroth block ID. This is one. This is two. First, we have to find which block we have to go. So we will write block ID x dot x because we are using this as the 1D. So block ID x dot x into block dim dot x. So it will give you that you have to move inside this which block. So either you have to go block 0 or block 1 or block 2. If you will do the computation mathematically, you will understand that which block you have to go. Now after doing this, you are inside the block. Now you have to add offset to that to approach to this thread number 1. So we will do plus thread ID x dot x. So this is the approach and visualization for how we have to calculate this. So any problem in this for calculation of 1D grid and 1D block?
No, sir.
Although I guess this is easy, but uh, this is going to be helpful for the calculation of 1D, 2D, or 2D, 2D, because it's difficult for visualization of 2D, 2D, right? So if you will understand this, then it will be easy to understand the 1D, 2D, and 2D, 2D. So is this fine for all, or I should repeat it once more?
So can you please repeat it once again?
Sure. So what is that? Is that you are given in the question, you need to launch the kernel with 1D grid and 1D block. So what you have to do is that you have to, since, so assume that this is a x-axis, this is a y-axis. But y is not required here because you have to do with all the calculation with 1D grid and 1D block only. So you have to be confined yourself in the x direction only. Now, what we have different number of blocks inside the grid, like block 0, block 1, block 2, and so on. Like it might be continue other blocks also. And inside the block, we have some threads also, like thread 0, thread 1, thread 2, thread 3, and so on. Now, the the thing is that we have to calculate the thread ID, right? So that is the main thing, that how we will pick the particular thread out of this 1D grid and 1D block launch. So just like the, like how we will calculate that thread ID, that's what I am telling you. How, what is the approach? So assume that, just assume that we have to calculate it for thread 3. So for thread 3, this is thread 3. You can I am pointing it. This is thread number 3. So for calculation of thread 3, what you have to do? You have to first find the block, which block you have to go, and inside the block you have to find the thread. So finding the block, how to find the block? Then we have to do some computation to find the block. So for finding the block, what we will do? We will do just block ID x dot x into block dim dot x. So it will give you the uh, block in which the particular thread is there, and inside the block, like we will add some offset, like, and we will approach to that thread plus thread ID x dot x. So this is the way that you have to do. Similarly, if I will do for just clear, it is fine, right? I should clear it.
Yes, sir.
Yeah. So now, if you will tell me 1D and 2D, right? So 1D grid and 2D block. So like, just you need to visualize it and you will do it. You need not to learn or remember anything. Just understand that how. So this is your outside is your grid, and what is there? So you have 1D grid and 2D block. So block will be in the 2D, right? So what is going to happen is that this is your block. Assume for two blocks now, because we have less space here, and it might be possible that you have more blocks. So this is your zeroth block, this is your 1th block, right? And inside the this block, you have different number of threads, right? So this is going to be like thread 0, thread 1, and like we can take others also, thread 3, thread 4. For this also it might be like that. So this is your thread number 0, this is thread number 1, this is 2, this is 3, this is 4th, this is 5, this is 6, this is 7. And now assume that you have to do the calculation of thread ID for this number of thread, right? Thread number 3. What do you have to do? First, you need to approach to the block. If you are inside the block, since this is 1D grid, so you should not worry about this grid. If it is 2D, then we have to worry. Since it is a 1D grid, the problem is with the 2D thing, right? So what you have to do? You have to just approach to the block. So block number 0. First, you have to go to block number 0, and then here you have to do the traversal. How you will traverse it? Like this. Suppose like this. Okay, so you will come like this, or it will be like this, I guess. how you will approach to this. Okay, so how you will do this calculation inside after coming to this block. So that you have to do. So what we can do is that we can do this calculation by how we can write. We can write it as a block id x dot x into block dim dot x into block dim dot y. Right. If I will do this, then what we will do? And after doing this, now we have to traverse, right? Now we have to do some traversal, right? Suppose it's not only three threads; it can be more threads also. So for that, we will do thread id x dot y plus block dim dot x. And after going to that, now we have to add some offset to that, and we can add it plus thread id x dot x. Is it fine?
Yes, sir. Understood.
So this is the approach that you have to use in order to understand this type of launch, because if you have to like row measure order or column measure order in the matrix, similar way you can understand this also. Uh, but if you have any more problems, you can tell me. The time is already ticking, and I am just exceeding my time because my time is limited. It's 30 minutes only. It's 9:34 already. So if you have any like more doubt, you can tell me, and then we can stop.
Yeah, I think in the interest of time, we can take up more questions maybe over email.
Yeah.
And I'll stop the recording now and then start the session for the second class.
Okay.
All right. Thanks a lot, Ashwin.
Yeah.
Okay, let me share.